So first one on the chapter 9 review is a perfect square. When it's a perfect square, I don't need to see a factor tree. You can do one if you want. It's not required. Does anyone know the square root of 64? It is the number 8. You do not need a square root if it's a perfect square. Don't put square root 8. You will get it wrong. Okay? Once you find out what number times itself gave you that number, the 64, you no longer need a square root. What's the answer for number 2? 4. Also a perfect square. You can see in the directions the first 5 are perfect squares. Number 3. 2. Again, no square root. You found the square root of 4. It's just the regular number 2. Number 4. 9. Good. Number 5. 6. Great. All right, here's where the trouble starts. 80 is not a perfect square. So we need to do a factor tree. Can anyone tell me 2 numbers that multiply to give you 80? 8 and 10. Good. And then you got to keep going.
I thought it was 2. I would never remember.
You could do 2 and 40 if you want.
8, 4, and 2.
Yeah, there are multiple ways to do this, but if you're doing it correctly, you should end up with all the same prime numbers as we are, even if you didn't start with the 8 and the 10. All right, so our prime numbers here are 2, 2, 2, 2, 5. Which ones are the repeaters? We have 2's here. So I'll have a 2 in my answer. Anything else? We have another set of 2's. So I'll have an additional 2. And then who's stuck inside the square root? 5. Good. I'm sort of out of space, so I'm going to write my answer up here. In the front, I have 2 times 2. What's 2 times 2? So 4, and then square root 5. Raise your hand if you have any questions. All right, we can go to number 7. What's the tree for number 7 look like? 9 and 10. 3 and 3. 5 and 2. Good. So our prime numbers are 3, 3, 2, 5. Who's coming out? The 3's. Who's staying inside? The 5 and the 2. So you multiply those together. What is 5 times 2? 10. So your final answer here is 3 on the outside, 10 on the inside. So we say 3 square root 10. All right, number 8, square root 12 is not a perfect square, so we got to do a tree. What's the tree look like?
6 and 2.
6 and 2 will work. 3 and 2, good. Who comes out front? Who stays inside? The 3, very good. Raise your hand if you have any questions. All right, let's jump down to number 9. Square root 45. 45 is not a perfect square, so we need to start with a tree. 5 and 9. 3 and 3. 5's prime, 3 is prime, 3 is prime. So now you can start pairing them up.
3.
These go together. So they're on the outside. Who's stuck on the inside?
5.
The 5. Great. All right, next we have 50. How does that one break up? 25 and 2 will work. I heard someone say 5 and 10. That will also work. You can do either one. All right, does the 2 go any further?
No.
All right, what about the 25?
5 and 5.
5 and 5, good. So if you did 5 and 10, the 10 would go to 2 and 5, right? So you'd still end up with 2 5s and a 2. Everybody see that? All right, so who's on the outside? The 5. Who's on the inside? The 2. Good. All right, 32. Thirty-two. 8 and 4. 8.
4 and 2.
4. All right, so we have a 2, 2, 2, and then back up here we have another 4, which is a 2 and a 2 again, right? So we have 5 2s. That's a nice one. Who's busting out? 2. 2. So out front I'll have 2 and 2. Who's on the inside?
2 and 4.
You only use the prime numbers, the bottom branches. So the 4 we broke up to 2 and 2, so we can't use the 4. But we can use this lonely 2, right? So out front you have 2 numbers. You got to put them together. What's 2 times 2?
4.
So 4 square root 2. Questions? All right, what about 63? $63. 7 and 9. What about the 9? What about the 7? Nothing. 7 is prime. That's why if you're looking at the factor sheet I gave you, 7's not on there. The only factors of 7 are 1 and 7. Okay? The only factors of 3 are 1 and 3. We good? All right, who's a repeater? The 3. Who's not a repeater? 7. Stuck inside. So sad. Poor 7. All right, last year when I gave this test, like half the class left 13 blank, okay? There was a 13 stuck right in there tomorrow too, okay? So don't do 12 and then jump to 14, okay? Use those math skills. There's a number in between. Find it. It's hiding right over here. Okay? My bad. Poor design in the worksheet. But you are responsible for it. So don't lose it. All right, 96.
I said 2 and 48.
2 and 48, okay? 2 is done. What about 48?
6 and 8.
6 and 8 will work. Good. 6 is
3 and 2.
good. 8 is
4 and 2.
good. And 4 is
2 and 2.
oh my goodness. All right, so I have these 2s, right? I have these 2s, right? Who's on the inside? Yeah, there's a lonely 3 and there's a lonely 2. Tricky one. What do I end up with on the outside? 2 and 2 make?
4.
Okay, and on the inside? 6. Good. Make sure you're multiplying those together. The leftovers on the outside multiply. The leftovers on the inside multiply. Any questions? So now the questions are worth twice as many points. These are 4 points apiece. But there's less of them. There's only 6 of them. Okay? So this is all from 9.2. Now, I want you to circle part of the directions right here. When you're studying this towards the end of the hour and tomorrow in your classes leading up to my class, I want you to keep referring back to this idea that you need a plus or minus in both answers. Remember, when you're solving an equation, you're finding out what makes this true. What could I plug in for x and get something that's true? And squaring a negative number gives you the same thing as squaring that positive number. So you have to think of both, or you're only giving me half of the solutions, and you're only going to get half of the points. Okay? There is a large penalty for the plus minus. Do you understand? Yeah, yes. Yes, thank you. Some sort of affirmative is great. All right, number 4, we need to undo squaring the x. How do you undo squaring something? You take the square root. So I need to take the square root of both sides of the equation. The square root and the square to undo one another. I'm just left with x equals, this is where you instantly go plus minus. Now, what is the square root of 25? 5. This is a perfect square. You get an answer right away. Boom. Now, are there any other super easy ones? Number 16 is a super easy one. Why? Because these are perfect squares. So if this was my test or my quiz tomorrow, I would just knock out all the perfect squares right away. They're way, 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 way easier. Okay? So I'm just going to go boom, boom. Don't forget your plus minus. 3. Good. Now, let's say you're struggling with the list of the perfect squares. You haven't quite got it in your memory. You're not sure if you could pick that out yet. Well, over here, when you start doing a tree, you'll see everything's a repeater. So you have 2 3s that come out to the front and nothing left over in your square root. Okay? Nothing means you can drop the square root altogether. So you just have plus or minus 3, no square root. So even if you don't recognize right away that it's a perfect square, your tree should give you some really good indicators, because everything on the tree will be a repeater. Okay? Same thing for number 19. This is a perfect square. So we take the square root of both sides. We get x equals. Sneak your plus minus in there. This one is 11. Questions on the perfect squares. Like I said, these are like way easier than the other ones. I've got high hopes for you all getting these correct. I have high hopes for you getting all of them correct, but they're extra high on the perfects, okay? 15 is not a perfect square, but the setup is the same. We're going to take the square root of both sides. That leaves me with x equals plus minus. Now, you can either do the tree right from this number, or for these, I usually do the tree off to the side. So 98 is what?
7 and 14.
7 and 14. Okay. 14 is 2 and 7. 7 and 2 are both prime, so I'm done. Who's coming out? The 7s. Even though they're not right next to each other, there's still 2 of them. So plus minus 7. And then who's left inside? The 2. It's like, wait for me, 7s. And they're like, nope, bye. All right. And the 7s stick together. You got 1 7 on the outside. You got 1 2 stuck on the inside. Don't forget your plus minus. Don't do all that work and then lose half the points because you forget a plus minus. Questions? All right, number 17. What should I do to both sides? Take the square root of both sides. Good. The square root of x squared, the squared and the square root undo one another. We have x equals, immediately put plus minus before you forget. All right, and on our factor tree, we have 6 and 4, 2 and 3, 2 and 2. Who's coming out? Who's staying inside? Can I leave my answer like this? You cannot. You have to change that to a 6. Very good. Now, see all this stuff? Definitely put boxes around your answers, okay? It just tells us what you actually want us to check. All right, final problem. What do I do to both sides? Square root, square root. X equals plus minus before you forget. Do it. And then we can do square root 40 over here. Did we already do 40 up top? I feel like I've done this tree before recently. Didn't we do 4 and 10, 2 and 2? Am I making this up?
You did 45.
Maybe we did it yesterday. Anyway, sorry. The tree's fresh. There it is for you. 2's come out. Stuck on the inside is 2 and 5. What is 2 times 5? 10. So I'll have plus or minus 2 on the outside, 10 on the inside. Now, lots and lots and lots of ways these could go wrong. So when there's this problem with many, many, many steps, the best thing you can do is write out all your steps. The more steps we see, the more partial credit we can give you when we're grading these. All right? So there's no such thing as too many steps. Write them all. Show us what you're doing. We'll try to give you as many points as we can. Okay? Now, you have the rest of class to study and to work on old homework. That does not mean listen to your music super loud or play on your phones. Okay? Everyone understand your expectations. If you have questions, let me know. We're here to help. But again, quiet study hall. So class is done.